Okay, what am I going to talk about? I am going to talk about the JVM architecture. What are the memory locations that we have with respect to Java here? Okay, now what I do, see here, I will develop a class. Okay, see, just concentrate for one program here. Okay, that's more than sufficient. If you have a class, and the class name is demo. Okay, open curly braces and close curly braces. Done. Now I will have one variable. See, static. Okay, static int x equals to 10. This is a static variable. Looking at the program, I can easily tell. Correct. And I'll also have one non-static variable. Int y equals to 20. So easily we can differentiate between a static variable and a non-static variable. Sir, if a variable is declared using static keyword, it's a static variable. If a variable is declared using no static keyword, it's a non-static variable. Similarly, I will have one method. See, static method. Static void m1 method. Okay, open curly braces close, and I will just write one line of implementation, that is SOP high. Okay, I'll just write it as SOP high. And I'll also have one more method here. Okay, one more method, that is a non-static method, that is void m2, open parenthesis close, open curly braces close here. And again, I'll have one line of implementation, that is SOP by here. Okay, this is all about it, guys. Okay, this is all about the entire process. Okay, now imagine. Okay, now imagine I have my main method. Okay, I have my main method wherein the execution will always begin from. Correct. Okay, execution will always begin from. Right. So now here, first of all, understand, closely observe. When I execute my Java program, okay, so there is something called as static variables and static methods here. I am trying to print it. See, system.out.print. I am trying to print a static variable, and I am calling the static method because static variables can be accessed directly within the same class. So now what happens, there is something called as class area. Okay, what is that? There is something called as class area. Correct? This is nothing but class area, or we also call it as static pool here. Okay, and what is the name of the class area? It's demo. Why? Because I am going to load all the static properties of class demo here. So once I execute my Java program, the class loader, okay, will load all the static properties into the memory. So there is a static variable x, he will load that first. X will get initialized to the value called as 10 here. He will initialize to the value called as 10 here. Done. And one more static method should also get loaded. Void, okay, m1. It is pointing to some address 0x1. Okay, it is pointing to what? It is pointing to some address 0x1, wherein the implementation is stored. That is SOP high here. Okay, now this is what we are supposed to understand. Okay, so this is nothing but method area, and this is nothing but the method area. Done. After that, it is pointing to some address 0x1. Clear? So this is called as method area, where the method implementations are stored here. Got it? All the static properties got loaded within the memory now. So what happened here? Class area or static pool is a memory location wherein the static properties are loaded. See, x is a static variable and it is initialized to the value 10. And there is a method called as m1 method. It is pointing to some address 0x1 wherein the implementation is stored here. So method area is a location wherein the method implementations are stored here. But what about non-static? Sir, we haven't created an object yet, sir. So therefore, what happens here? Non-static properties will not get loaded. I will create an object. See, I will create an object. Demo d equals to new demo of. I create an object of demo. Now what happens here? There is a memory location. Okay, what is that memory location called as? That memory location is called as heap area. Heap area is a location wherein the objects are generally created. Where the objects are created? Inside a memory location called as heap area. When I tell new, an object will get created with the address d here. Okay, with the address d here. Now all the non-static properties should get loaded. So which is the non-static property? It's y. Y will get initialized to the value 20, and it also has a non-static method, that is m2. Okay, m2 method, and that will also point. Okay, wait just a moment. Void, okay, m2. It will point to some address 0x2 wherein the implementation is stored here, wherein the implementation is generally stored here. Okay, so this is pointing to some address 0x2. Okay, it is pointing to some address 0x2 wherein the implementation is stored here. Okay, just a moment. I'll explain it, guys. Okay, don't worry. I'm going to explain it in a beautiful manner here. So just concentrate. Okay, here SOP, by is stored here. Clear? This is all about it. This is all about the entire data. If I want to print, I will tell SOP d.y or I'll tell d.m2 method. That's it. Non-static. Got the clarity here? If you just go back to the process here, the JVM architecture. See, heap area is a memory location wherein the objects get created inside the heap area. And class area or static pool is a memory location where all the static members would get loaded there. And the method area is wherein the implementation of the methods, the implementation of the methods are stored here. Got it? What is stack and native area? I'll tell you. Okay, what is stack and native area? I'll tell you here. Okay, got the clarity, guys? So I have a class. All the static properties are loaded inside a memory location called as class area. And x is pointing to 10, and m1 is pointing to some address 0x1 in the method area where the implementation is stored. Correct? And then when I create an object here, objects will get created within heap area. Okay, and here the non-static property y and m2 method. Y got loaded to the value 20, and m2 method is pointing to some address 0x2 wherein the implementation of that method is stored. That is present in method area. Okay, and the execution will always happen inside a stack. And what is the working of a stack? I will tell you here. Don't worry about it. Okay, so these are the few things which we are supposed to understand when it comes to the program here. Got the clarity here? This is all about the process here. Clear everyone here? And what is stack here? Okay, I will talk about it. Okay, see here. If I have my Java program, stack is the location wherein the execution will always happen. See, I have a class called as A. Okay, now within that class, I will have one method, static. Okay, void m1 method. Okay, m1 method. So here I will write sop1 here. Okay, and here I'll have my main method. Okay, I'll have my main method. How? Public static void main string array of arguments, open curly braces, close. Okay, so here I'll give the implementation as sop start. Okay, I will call the m1 method, and I'll tell sop end over here. I will call the sop end. So now the execution will always happen inside a stack, no? Okay, the execution will always happen inside a stack. Okay, so now here inside a stack here, wherein the execution will always begin from, the execution will always begin from our main method. This is my main method wherein the execution will begin from. Correct? So what are the three lines of implementation it has? SOP start. Okay, I will call the M1 method, and SOP, and I will call the end here. This is all about it. So internally, what will happen here? The execution starts from start, no, SOP start. So start will get printed, and then M1 method. I am calling the M1 method. So once I call the M1 method, upon that, the M1 method will get called here. And what is this? When this M1 method will get called, what is the output here it has to print? SOP1. Correct. So one will get printed. Okay, one will get printed. After the execution is done, no, automatically the control will come back here. It's like push. There is a stack, and once you keep on adding the elements here, it's called push, and the pop meaning the elements comes out. Push meaning adding, pop meaning removing. Once you call the method will call. The execution will happen, and the control will come back to the caller. And what is the next line here? End. So end will get executed. So this is called as the basic working of stack here. One upon one, one upon one, one upon one. It keeps on calling here. Got the clarity here? Understood everyone? So stack meaning this is wherein the execution will always happen from. Okay. Now in this program here, let me do one complete program. Okay. So I'll just take the class name as test here. Test is there. I'll take the class name as runner. Okay. Now here you have to concentrate here for one moment. Static void m1 method. Okay. So I will just write it as, okay, just a moment guys. Let me develop the program here so that you can understand in a beautiful manner. Okay, sys out. I will just write it as, okay, sys out. I'll just write it as hi. Okay, I'll call int result equals to m2 method. Okay, and here I will write it as sys out by plus result. Okay, by plus result, and then here I will also have one more method, void m2 method. Okay, so I'll just tell return 20. Okay, so here this is also a static method. Okay, so and here I'll have my main method wherein the execution will always begin from. So here I will just write it as sys out start, and I'll call m1 method and sys out end here, and here the return type will be int here. Okay, now great. I'm done with my program part. Okay, I'm done with my program part. So now here, when I execute it, what will be the expected output is what we are supposed to see. So now here, I will execute it with respect to one stack diagram here. Okay, so that you can understand on the code as well as I'll be executing it over here. Okay, so both the things you can just analyze and get to know it. Okay, simultaneously. Okay, so just guys, in this specific program here, okay, execution will always happen inside a stack. No, okay, there is always something called a stack. Okay, stack is wherein the execution will always happen from. Okay, now this is nothing but stack. Okay, and then here wait, this is for main method, this is for m1, and this is for m2. Yeah, sufficient. Okay, now we're done with this entire process. Now generally the execution will always happen where the execution will always happen from the main method. Public static void main, this is wherein the execution starts. Within the main method, what is the lines of implementation? So it is like SOP, I have written it as start, correct? Then I'm calling m1 method and SOP, and the output is end here. So what happens initially? start will get executed, correct? This line will get executed. And now when I try to call the M1 method, the M1 method will get called here. Okay, M1 method will get called. Now what is the lines of implementation in the M1 method? So it is doing certain set of things. SOP, it is printing hi, okay, and at the last it is printing SOP by gives a space plus result here. Okay, so here it is storing the result over here. Result equals to M2 of. Okay, now so now what happens next here? Start got executed. I call the M1 method. Hi will get printed here. And now when I tell M2 of, I am calling one more method. Which method? M2 of. Okay, I call the M2 of method. And what is the implementation of the M2 method? It is telling return 20. So when I tell return 20, the control will come back to the caller and he will give 20. The 20 is stored into result here. Okay, what is the result value? 20. Then next, what is the line here? By 20. So by 20 will get printed. After the execution has happened, automatically the control will come back to the caller. And next here, end here. Start, high, by 20, end. This should be my output here. So when I execute my program, just look at the output. Will I get the same output? See, start, high, by 20, end here. So this is how we are supposed to understand. See, start got executed, no. Then I call M1 method. I call the M1 method. High will get printed. M2 of meaning, I call the M2 method. Return 20 meaning, I am explicitly transferring the control back to the caller with the value 20. So 20 is returned here. The 20 return value is stored into result. And what is the next line? By 20. Once the execution has happened, you write return, you don't write return. The stack will happen automatically. The control will come back to the caller. And what is the next line? Enter. So this is the stack diagram which you need to understand. I've written the most ugliest way possible here, but I hope I have explained the concept here. Okay, this is what we are supposed to understand.